For part B, we're asked to find the absolute maximum value of g on the interval from -3 to 7. Justify your answer again, so we need to back up our answer. So, again, forget about this problem for a second. Just in general, when we talked about absolute maximums, what did we have to figure out, or what did we have to remember? What do you remember about absolute mins and maxes? Plugged everything in? What do you mean plugged everything in? Critical values and the endpoints, right? So normally absolute minimums and absolute maximums, or a lot of problems that we did earlier, we were given an equation, and we found the critical value. So we found the derivative, set it equal to 0. Those are the critical values. Then we checked those points, those critical values, and the endpoints to see what's the absolute highest, absolute lowest point. So with absolute maximum, we need to remember the endpoints. All right, so we need the critical values and the endpoints and check those. Well, critical values, like I said, normally we'd take the derivative of the function, set it equal to 0, and solve, and those would be our critical values. It's easier here. We have the graph of the derivative. When is the derivative 0? -1, 2, and 6. Right? At these points, the derivative of g is 0. Those are critical values. Right? So those are our critical values. Now, I think we're more comfortable looking at derivatives on just like a little derivative number line. So this may help you to kind of figure this out. You may not need this, but here, the first time the derivative is 0 is at -1. Then the derivative is 0 at 2 and 6. All right, so normally then we would go ahead and plug in values to our function to figure out when the derivative is positive or negative. But here we can look at the graph. To the left of -1, remember this is the graph of the derivative, so the y value represents the derivative. The y value here is always negative. Right? It's below the x-axis. Y value is negative. Then between -1 and 2, the y value is above the x-axis. So the y value is positive, which means the derivative is positive. Between 2 and 6, the y value is always negative. And then to the right of 6, the y value is positive, so the derivative is positive. So what kind of a point do we have here at -1? Local min. Right? Key is the local minimum. Here at 2, local maximum. So this is a candidate for absolute max. Right? We're not going to check this one. There's no point. We know it's a minimum. And then this one, another local minimum. So we're not going to bother with that one either. So we need to check our local maximum and our endpoints, -3 and 7. So for part B, we're going to need to figure out g of -3, g of 2, right? That's our local max. But hey, look at that one. We lucked out. That was given to us in the directions. It says g of 2 equals 5. So we know our local maximum is at 5. But then we also have to check the other endpoint, g of 7. Those we need to figure out. And to figure those out, we need to use a formula that we talked about before. Pretty big one in general. No, not a big algebra formula, a big calculus formula. All right, so for this one, it's basically just the fundamental theorem of calculus, just kind of shifted around a little bit. F of b equals f of a plus the definite integral from a to b of the derivative of f of x dx. All right, we did some problems with this not too long ago. It was a while ago, but this is a key formula. All right, this is a way that we can figure out a value on the original function when we have a starting point, one point from that function, and then the derivative. So this is what we need to use to figure out g of -3 and g of 7. So to use this, what we would be doing, we want to figure out g of -3 Well, we're going to use the one point from the original function that we know, g of 2. Because we know what that's equal to. Plus, then we're going to do the definite integral from 2, right, this value is a, to negative 3, this one, of the derivative of g of x dx. Basically what we're doing here is we have this value we're starting from, this definite integral from 2 to negative 3, that's like our displacement. That's how much the original graph has changed, right? Derivative is the rate of change. When we add up all those rates of change, it tells us how much it's changed from this point to this point. Now, it's a little messed up because the bigger number's on the bottom, smaller one on top, but we can change that. I'm going to go ahead and replace the g of 2 with what we know it is, 5. But we can change this and put the negative 3 on the bottom and 2 on top, but if we do that, what else do we have to do? Make a negative on front, right? Subtract, because that's going to make it the opposite. So basically we're taking 5 minus the area under this graph from negative 3 to 2. So the area from negative 3 to 2. So we're looking at all of this and all of this. Right? Definitely from negative 3 to 2 means this area plus this area. Well, use a little basic geometry to figure that out. For this one, we have a triangle. It's 1/2. Base is going to be 2. And the height is going to be negative 4. Right? Below the axis, remember, it's going to be a negative area. So we end up getting an area for this part of negative 4. Over here, we're going to have a positive area. It's above the x-axis. 1/2 times the base is 3. Height is 1. So we get 3/2 or 1.5. So if we combine those, negative 4 plus 1.5, we get negative 2.5. Right? That combined gives us negative 2.5. That's our change in g from negative 3 to 2. So g of negative 3 is going to be 5 minus negative 2.5. So really it's going to be like 5 plus 2.5. So g of negative 3 comes out to be 7.5. So already we know this is bigger than this one, so this could be our absolute max, but we need to check g of 7 first to make sure. Right, for g of 7, we're taking g of 2 plus the definite integral from 2 to 7 of the derivative of g of x dx. And we know g of 2 is 5. And we can figure out the definite integral from 2 to 7 by finding the area under the curve. So from 2 to 6, we have a triangle below the x-axis. 1/2 times 4 times negative 2, we get an area of negative 4. Then from 6 to 7, we have a triangle above the x-axis. 1/2 times 1 times 1, so we get 1/2. Combine those areas and we get negative 3.5. So 5 plus negative 3.5, we get 1.5 for g of 7. So here are our 3 points, our endpoints and our local maximum. So obviously our maximum, the highest point, is going to be 7.5. So for part B, the absolute maximum we should specify of G is at negative 3, 7.5. And to kind of justify our answer, that this endpoint is higher than the one local maximum on this interval.